Yeah. So, can you see this screen?
Yes, sir.
Yes, sir.
Okay, so in the last class we started with image processing. Okay, and, and we saw some of the very fundamental operations. When you have any biomedical image, we want to pre-process the image. Okay, not for just modeling, sometimes for modeling, like predictive modeling, sometimes also for better visualization. Okay? Better visualization before giving it to the, let's say, the doctors or other people. So for better visualization, then removing any kind of noises. Okay? Sometimes the image can be noisy. Depending on the measurement device, the image can be noisy. So you can actually you might want to remove the noises before actually processing it further, using it further. So removing noisy pixels. Okay. Then sometimes enhance the quality. Okay. Or sometimes you want to focus on the segments, different segments, because the edges. You want to know the shape of the object. The object means the RY, region of interest. You're only interested in that one. Okay. You might want to identify the shape to understand how the identify the edges to understand the shape of the RY. So there are different processing techniques, lots of different techniques, and these techniques varies. These techniques varies with the different imaging modalities. So for an X-ray image, there can be some techniques. Those same techniques may not be suitable for ultrasound image. Ultrasound image might need different types of techniques. MRI image will need different types of, because this X-ray is usually the 2D image. Okay, the MRI is 3D image, so you have to process the volumetric images in case of when you're working with MRI. So it varies with different imaging modalities. So we'll try to look at some of the techniques, some of the common techniques that will appear again and again. And based on this, you will have your lab 4. Okay. I have already, so whatever you learn in the theory, many of the things you will also see in the lab 4. What happens when you actually use an image and you can see the output. You can use your own image and see the output when you try to apply those techniques. So in the last class, we started with some of the very common techniques, that is the image enhancement. Image enhancement is a very fundamental image processing technique that you want to enhance the enhance the quality of the image. You can do it using contrast enhancement. Okay, you want to increase the contrast of the image, make it two different segments much more clear. That's the contrast. Okay. So there is different ways you can do this. One of the ways was histogram equalization. We talked about histogram equalization. That is one way. This histogram equalization also have variations, adaptive histogram equalization and others. Next, there are other techniques. There are other techniques like gamma correction. You will show the effect of gamma correction in the lamino. Okay, this is another technique of contrast enhancement. Okay, so this is enhancement. There are other techniques, several other techniques we might see in the lab. Today we are going to discuss more about filter operations. Okay, filter operation. Filter operation. Now, one thing is that this was point processing. Point processing means every pixel every pixel value we will have will be updated based on only that pixel value. Okay, like a one-to-one mapping. Okay, like in gamma correction, whatever what you do, whatever the pixel value that you have, whatever the pixel value that you have, you multiply it like with you make to the power of gamma. Okay, so to get some non-linearity, so that's why that you do, and you do it for each pixel value. So and the corresponding pixel value is your output. So that is your point processing. But the filter operations are mask processing. Okay, mask processing means you take the information of the neighborhood. Okay, and based on the neighborhood, to modify your image. So neighborhood information is also needed here. Okay, 1 second. So neighborhood information. So if you have something like this, all the pixels in the image, let's say when you try to change this, modify this pixel value, what do you do? You take the information of all the surrounding pixels. Okay. So you take the information, this one, 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 this one. If you are using a 3 by 3 mask, okay. If you use a 5 by 5 mask, then you have to make it even larger. Okay. So this is the when you do filter evaluation, you take the information of all the neighborhood pixels, and based on this, you get some output. And in the modified image, you change this value, update this value with some modification. We'll see how we actually perform this operation. But that's actually the mask processing. Okay. And this type of filter is like there are lots of different filters. You are already familiar with frequency domain filtering. Frequency domain filtering operations, like for instance, low pass filter, okay, high pass filter, then band pass filter. You are familiar with these things. Low frequency, high frequency component, things like that. But here, when you are working with images, here we are working with images. This is more easier to understand when you are working with, for instance, signals. Signals have a particular frequency that way. But when you're working with images, it is more easier to consider the spatial domain. Okay, so we are talking about filtering in the spatial domain. That means we are talking about filtering based on the values, okay, that we can see exact values in the image pixels. So in the spatial domain, we can also perform this low pass filtering, high pass filtering, band pass filtering. All this operation, they can also be considered in terms of a spatial domain as well. Okay, and we are going to focus on that one. So you can ask, so what is frequency in images? What is low frequency in image? Just like I said, a spatial domain. So low frequency or high frequency, low frequency, high frequency. What does it mean? Low frequency or high frequency components in images. High frequency components in an image. So you see, if I'm considering some values like this, let's say all the values are 0, 1, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 20, 20, 20, 0, 0, 0, 0. Now, if you consider this one, these pixel values, you see most of the values are like what 0 and 1, something like this. And you can see from this region, there is a sudden change in the region, right? Are you following?
Yes, sir.
Okay. So there is this sudden change in the region. The rest of the pixels are almost the same, but somewhere in the middle there is a sudden change. Okay, so if the rest of the regions are somewhat like, you can say, if the rest of the regions are like black, in somewhat black, in this region you have some white pixels. Okay, some white color pixels here. Then again you have some black color pixels. Okay, if you think of it like this. So this can be like, for instance, when you are taking the image of a face. Okay, image of a face. Okay, you see these regions, when you are in these regions, all these regions are almost same. The pixel values are almost same. Whenever you encounter an edge, whenever you encounter an edge, then the pixel values will certainly change. Are you following?
Yes,
In
sir.
these regions, you have the same pixel values. Whenever you encounter an edge, the pixel values will suddenly change. You can ask questions. Okay. Again, in these regions, you have similar pixel values. All the pixel values are almost same. But suddenly, when you face an edge, okay, or then you actually have, when you in this region, then you have a certain change in the change in the values of the pixels. So in terms of images, that's what the frequency is. These regions are low frequency, no change in the pixel value, or very small change in the pixel values. Whenever you have these sharp changes, that is the high frequency components. Okay, so in high frequency components follows like the edges of the image, edges in the image, or sharp details. If you have any sharp details in the image, those are high frequency, or texture, things like this. These are the high frequency components. That's why there is a change in the image, certain change. Are you following? Is it clear?
Yes, sir.
So
Yes.
this is the concept of frequency in images. Okay, you have the low frequency components, you have the high frequency components, and we are going to see this how these filter operations work in the spatial domain. In this domain, just looking at these pixel values, how we can actually work with this form. Okay, acha. Now, so this filter has different purpose. Different filtering has different purpose depending on what type of issue you are facing with your image. Okay. Let's try to see some of the common things. First of all, low pass filter. Okay. What's the low pass filter? That means you are going to allow low frequency, right? You are going to allow low frequency. You want to block the high frequency components. That's what your low pass filter is look like. So in terms of image in a spatial domain, that means you want to allow these small variations, but you want to suppress this change, these edges. Okay, so you want to suppress the high frequency components গুলোকে suppress করতে যাচ্ছ. You want to suppress these high frequency components. So what will happen in that scenario? This is like you will get a smooth version of the image. So image smoothing. We'll see how a little bit later. Wait, or it will slightly blur your image, blurring, and it will like reduce the noise in your image. That's what your low pass filter will do. It will provide a smooth version. When you pass a low pass filter through your image, it will provide a smooth version of your image. It can slightly blur your image. Okay. It will reduce some of the noise components in your image. So noise reduction is like, well, they will remove some unimportant details from the image. Achha. So let's see how we can actually perform this kind of filtering. So in a spatial domain, filtering means using a mask. Okay, mask or weight kernel. You see, if I consider 3 by 3, that is what you actually use, 3 by 3. So if I do like this, 1, 1, 1, 1, 1, 1, 1, 1, 1, এখানে আছে 9 pixels, so 1 by 9. আচ্ছা, so what we do, let's say this is your mask. Okay, this is your mask or kernel. So what do? You perform a convolution operation, right? Whatever your image values are, you perform a convolution operation. Okay. Do you understand? Do you remember these things from your earlier courses, how to perform these things?
Yes, sir. Sir, 1/9 টা কেন দিস?
To average it.
Okay, sir.
Wait a little bit. So let's say if you have different values, what you do, you take this filter and put it here. Okay. Then perform a point by point multiplication. You put it here, perform a point by point multiplication. Then whatever the value you get, point by point multiplication, then average. Whatever the value is, you replace this one, the center values, with that one. Achha. This will reduce the size of the image if you don't do padding. Assume that you have done padding. It's like, achha. So what will happen? So when you pass this filter on top of this image, multiply those things point by point, multiply those things point by point multiplication. Okay. Then take the average of this one, and whatever the value that you have here, you replace the value with whatever you get from here. Achha. Let's see something. Let's see. For instance, let's see the values that we have here is something like this: 2, 1, 3, 1, 9, 1, 2, 2, 4. Achha. Now see, what if I put this filter on top of this one? This is like masking. Okay. So what will happen? We multiply. So 1 multiple by 2 plus 1 multiple by 1 plus 1 multiple by 3 plus 1 plus 9 plus 1 plus 2 plus 2 plus 4. So if I sum all of them together, what will happen? So it is like summation of whatever here you have xi, yi values multiple by like pq, piqy values. Okay, summation of all those things. আচ্ছা, so you have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 25. You have 25. Okay, so you multiply point by point multiplication, then you take the average of it. So 25 divided by 9. If you take the average, what becomes to it? So this becomes 2.7. 2.78. So in the filtered image, what do? You replace this value. You replace this value with what value? 2.78. Are you guys following?
Yes, sir.
So if you replace the 9 with this 2.78, what will happen? What is the change? কি চেঞ্জ হচ্ছে? Wherever there is a
পিক্সেল ইন্টেন্সিটি কমে যায়।
স্যার 9 ওভার পিক্সেলের অনুযায়ী ভ্যালুটা এভারেজ হয়ে যাচ্ছে।
yes,
কমে
pixel valueটা average হয়ে যাচ্ছে. You see, whenever you have a pixel value, based on the surrounding value, it gets what? Average. So it is like an averaging filter. You're performing an averaging operation. So whatever, if there is a sudden variation in the image, sudden change, so this gets filtered out. It becomes something closer to the surrounding pixels, the neighborhood pixels. So if there is a high frequency component here, that also gets suppressed here. This high frequency component can be an edge, can also be a noise. A noise can be like a single pixel value that is suddenly very high. So that can be a noise. So this noise will be removed if you perform this kind of averaging. Are you following?
Yes, sir.
So this kind of operation, like when you talk about low pass filtering, that's what we are actually trying to do. You take this mask. So this mask is especially for averaging filter or low pass filter. What it will do, it will generate a smooth version of the image. Okay, a smooth version of the image. It will generate a smooth version of the image. Okay, so every value, now every value that you have in your original image will now be a average of its neighborhood. Okay, so the neighborhood has a lot of importance here. So if the name, whatever the neighborhood is, certain value will be something like that. Now you see, we used a 3 by 3 kernel here. We saw a 3 by 3 kernel. You can also use 5 by 5 kernel here. So what will happen with if you use a larger size kernel? If I use a
আর
larger, বলো,
আরো বেশি নাইবারকে মানে কনসিডার করবে, আরো বেশি সারাউন্ডিং কনসিডার।
so larger kernel, yes, more number of neighbors will be considered, of course. But what will be the effect?
Less information.
Less, more blurring, or averaging, whatever you say. So this in turn, you see blurring, because you see whenever you suddenly have a higher pixel value, different pixel value, it becomes suppressed. So ultimately, this makes your image a little bit blurred. Okay, so if you increase the kernel size larger, you make the kernel larger, the image will get more blurry. Okay, more blurry image will get, because you are now considering a larger vision. So more suppressing will be there. Okay, so this is the, yeah, this will be one of the effect. And sometimes you can actually, this is not the only kernel, you can have some other kernel. For instance, your kernel can also look like this. Okay, this is 4 2 2 2 2 1 1 1 1. Okay, and this will be divided by 1 by 16. Achha. This is also a low pass filter. So what is the difference? The previous one is like straightforward averaging, but this one is like adding more weight, to the central pixel. Weight to central pixel. Why it is doing that? Because you see, due to this kind of averaging or blurring, you are losing the high frequency components. So in low pass filter, you are losing the high frequency components like edges, sharp details, things like that. But sometimes some of these things are noisy pixels. Okay. But you see, sometimes you want to preserve the edge, you want to preserve the sharp details. Okay, you don't want this one. Okay, so low pass filtering does not mean you always want to actually let go all the edges. No, you want to preserve the edges a little bit. Okay, so you want to avoid that kinds of scenario. For this one, it will just not consider anything different averaging. But if you use this one, you see it is now considering whatever the central pixel is, it is now a little bit more weight. So it will not it will not be averaged just like before. The central pixel will still have some higher value. Also, the neighborhood pixels. So if it is like an edge, you can see now you are preserving some of the edge information, because an edge should come like this, a horizontal or vertical, things like that. So that is more preserved if you use this kind of filter. Okay, so you can actually reduce the blurring effect if you use the blurring effect if you're using this kind of wet mask. Okay, for your low pass filter. Are you following?
Yes, sir.
Let me see. So if you look at your can you see this screen?
Yes, sir.
Achha. Now this is like when you have like a noisy pixel, you can see the left one is a little bit noisy. It will be more clear when you actually open in your own PDF. I have already copied the PDF. So when you can also do it in MATLAB, you will see when you perform this kind of low pass filter, you can see the noises are a little bit like the image is a little bit blurred, but the noise is also suppressed here. Can you see it? The difference is very small, but it is visible if you look at it from very closely. So noise gets a little bit suppressed, okay, when you perform this kind of average. So image may get a little bit blurry, but it is better than the noisy ones. Okay. Acha. Let's come back here.
স্যার গ্রেন বেশি দেখে কি নয়েজ বুঝতেছি?
Yes, you will see in the if you look at the PDF, the lab manual, we actually intentionally added some noises there. That is called poison noise. Okay, poison noise means some small pixel values দেখা যায় যেগুলো হচ্ছে খুব ঝাপসা লাগে। Okay. আচ্ছা, now so we talked about low pass filter, and this was a linear operation, like just averaging. So this is like a linear operation. Now another type of filter is called the median filter. Now this median filter is a non-linear filter. It is a non-linear filter. Achha. What this median filter does is that it reduces the noise. It reduces the noise, but without eliminating edges or high frequency component. So one of the problem with one of the limitations of the low pass filter, the limitations or disadvantage of using this kind of low pass filter is that they attenuate the edges. Okay, they attenuate the edges or sharp details in the image. Okay, so in different scenario, this is something we want. We don't want to attenuate the edge. We want to preserve that information. But when you are performing this kind of averaging filter, when you are blurring your image or smoothing out your image, you actually have those things attenuated. So in median filter, you will have the reduction of noise, but without eliminating the edges. Okay. High frequency component. So what is median? So this performs the median operation. What is the median? Say if you have this kind of median filter does not use a mask. Okay, we used a mask here, then perform the convolution operation like this way. But in median filter, what do? You calculate the median values. So what will be the median value of this one? So what do? First, you take all the pixels. Okay, you take out all the pixels from like sort it.
ডিসেন্ডিং order.
On the descending or ascending order. So let's say you have 8, then you have 10, 10, 10. Then you have 12, 12, 24, 45, and 64. Total 9 pixels, right? So in total, you have 9 pixel values here. Achha. So you sort it and take the middle one. That's your median, right? So after in terms of median, if you have 9 pixels, the 5th pixel will be the median. 4 on the left side, 4 on the right side. So this value is 12. So what do? You change this center pixel value 24, you update this value. So in your updated image, what will happen? These ones will remain the same, 10, 10, 45, 64, 12. And the center one will be replaced by 12, the median of the neighborhood pixels. And it will perform this operation for all the images. So you will perform this one for this one as well. 64 will also get replaced like this way. So with the median value, so all the pixel values in the image will be replaced by its medians. Okay, is it clear how you're doing it?
The only
So
middle one will be changed, right?
only the,
Middle one will be changed.
yeah, if you have, yeah, only the median one. So everyone will be changed based on its surrounding. So this 12 will be changed. In that term, you will consider these values. You will have to consider these values as well. Okay, based on that, the 12 will also change. Okay, the whole image will actually follow this transformation. Is it clear?
Yes, sir.
So in the exam, I might give you like a pixel values of an image, like 20 by 20 size or 10 by 10 size of pixel values, and might ask you to perform a 3 by 3 median filter operation there, or 5 by 5 median filter operation there, and show it how it can change, how the output pixel values would look like. Is it okay? Acha. So when you perform this kind of operation, you can see the size of the image will be reduced, the resultant image. If you do it without adding anything outside, without padding, the size will reduce. That's fine. For now, you don't have to consider padding for now. Just reduce the size, that will be enough. Acha. Now, median filter. So you see what happens here. This value here. So when you are performing this filter, this is 24. It can be like 100, right? For instance, this value might have been 100 in the center. So if it was 100, it will still be replaced by what? 12. Right?
Yes, sir.
So if your middle value was 100, it would still be replaced by 12. So you see, it is not following that averaging criteria like the low pass filter anymore. What it was doing, it is just sorting and finding the median value. So the change is much more non-linear. It is not following any distribution. Okay. So whatever the value is, it can be sometimes quite different whenever some values here, like for instance, if it is 100, this value is quite different instead of this one. This is quite different than the neighboring pixels. And those values in particular gets removed when you perform the median operation. Something is very different than what is in the middle. Those values, like the outlier values, gets removed from the operation, removed by this operation. So that is like the noisy pixels. If there is a pixel value that is very much different than the neighbors, that noisy pixels will be removed completely by this median operation. This is how median filter removes the noises from the image. Is it clear? Is it clear?
Yes, sir.
আচ্ছা। So
স্লাইডিংটা কেমনে করবো বুঝছি না, মানে মাস্কিং অপারেশন না হলে মানে এই মানে এটা কেমনে পারফর্ম করবে এটা বুঝতেছি না।
just one by one তুমি চলতেই থাকবা। প্রথমে 3 by 3 সাইজ, তারপরে 3 by 3 সাইজ, তারপর 3 by 3 one স্ট্রাইক ধরে।
আচ্ছা
ঠিক আছে, just no convolution operation is here. আচ্ছা, so noisy pixels are removed. What about the edges? How they are preserved? You see, when you are in an edge, the edge, like, it should not be a separate pixel or a standard pixel that has very high value. So when you are doing this kind of filtering operation in terms of edge, the edge should follow like certain distribution. Like this can be whatever the restant of value is. So if it is like an edge value here, so 20, 22, 21, 18. So then you have 8, 7, 6, 5, 1, 2, 4, 7. So this can be, you can consider this is an age is here. Okay, an age can be there. So you see, when you perform the filter operation here, what will happen? 1, 2, 3, 6, 7. So this one will be replaced by 7. So if this is not a major change in the frequency, the median values will reduce, median values will reduce the age, but all the edges will be something like in the similar criteria. You see, all the middle pixel values will have the same criteria. And if the edges like extend a little bit further, like we'll see a little bit later, when you have edge, it does not always follow this only one column or one row. It usually follows 2 or 3 rows. Yes, information will be in 2 or 3 rows. So when you put the filter operation there, like the median filter, one edge, so out of these 3, one will be preserved. Okay, so in that way, median filter actually preserves the, at least some of the edges components will always be preserved in the median filtering operations. And in terms of noises, you see the noise can be different types. One can be like Gaussian noise. There is Poisson noise. There is salt and pepper noise. Salt pepper noise means very like some separate হচ্ছে pixel values that are actually different than all the others nearby ones. So this median filter is best at removing this salt and pepper noise. Noise can be different. So median filter is best for removing this kind of salt and pepper noise. It will provide, if your image contains salt and pepper noise, the median filter will provide a very good representation of your original image, removing all the salt and pepper noise. But the same median filter will not perform well when you have a Gaussian noise. So Gaussian noise is difficult to remove. So you need Gaussian filter for that. Okay. That's it. Now, so to summarize, this median filter will provide the smoothing effect to some extent. It will provide the smoothing effect. It will reduce the blurring a little bit. It will reduce the blurring. Okay, but it will reduce the noise. If not Gaussian. For Gaussian, it will not be very much successful. Also, if your image is too noisy, will the median filter work? তখন কাজ করবে কি মনে হয়?
না স্যার, কাজ করবে না।
Why?
তো স্যার শুধু
আরেকবার বলো। রিপিট, আমি বুঝিনি।
স্যার এজন্য মানে আমি মিডিয়ান করলেও স্যার এটা থেকেই যাচ্ছে।
You see, if the image is too noisy, that means
শুধু
you don't. হ্যাঁ,
শুধু সেন্টারটা নিয়ে কাজ করতেছে, লাইক ধরেন মানে আশপাশের, লাইক আমি যদি স্ট্রাইড 1 করে আগাইতে থাকি 3x3 নিয়ে, শুধু মানে মিডলের পিক্সেলটা নিয়ে কাজ করতেছে, মানে উপরের একদম ফার্স্টের পিক্সেলটা নিয়ে কাজ করতেছে না, ফার্স্টের পিক্সেলে যদি নয়েজ থাকে আর কি, মানে এরকম তো স্যার অনেক পিক্সেল
so
তো স্যার
actually what you do, you add some padding. You don't want to reduce the size of the image. So when you do padding, sometimes what you do, you don't just replace the padding values as 0. You make it same whatever the values you have. So in the edge, if you have 12, you make it 12, or sometimes the average of the neighborhood pixels like this way. So there are different padding types. Okay, so for now, just consider that you have no issues in the in the in the surrounding image, surrounding pixels. In the corner pixels, you don't have any issue. Just consider that all the information that you have, it is preserved on the middle of the image. Usually that happens. সবার লাস্টে একদম কর্নারে তোমার ইনফরমেশন গুলো সাধারণত থাকে না। তোমার ইমেজ ইনফরমেশন, ইফ ইউ ডুইং চেস্ট এক্স-রে, all the information is in the middle, not in the corner, রাইট? তাই না? একদম যে লাস্টে যে পিক্সেল গুলো থাকবে সেগুলো সাধারণত জাস্ট ইমেজের লাস্টের পোর্শন গুলো হবে। আচ্ছা, through noisy means you see all the image surrounding images have this kind of values, like high values 27, 21, 46. Okay, the zero, sometimes you have this 101, then 86, 46, things like that. So you see, when you have too much noise, the median will also be a noise, right? When you perform these operations like this, you are taking all the surrounding pixels and take the median. If the surrounding pixels are also noisy, the output will also be a noisy pixel value. ঠিক আছে না?
Yes, sir.
So that's why if your image is too noisy, the median filter will not work. Okay. আচ্ছা, so this is another operation. Just like low pass filter, median filter is another operations. There are different filters. Each one has their own operation. Different ones performs different tasks. It depends on what you want to do on the image. You want to make the image a little bit smoother, you take a low pass filter. Okay, things like that. আচ্ছা, now then you have high pass filter. So high pass filter means, okay, you see, it performs the opposite operation to the low pass filter. Okay, in high pass filter, you want to highlight the edges. You want to highlight the edges or high frequency components. You want to do this one, the opposite, and you want to reduce. You want to reduce blurring or increase blurring. The opposite of the low pass filter operation. So you want to, the main thing that you want in high pass filter is that you want to highlight the edge information. Okay. So how you can do this is something like this. The filter is something like this. High pass filter. You magnify the center pixels. So let's make it 8. What about the other ones? Make everyone -1. Okay, then you average. So what will happen here? You see, all the surrounding pixels gets suppressed, but the center pixel gets highlighted, right? Are you following?
Yes, sir.
So if it's like an area where all the pixel values are same, where all the pixel low frequency components, okay, then you see this is 8. The summation of the other components is also -8. So it becomes average out. So low frequency components becomes 0, no change. But whenever you have a high frequency component, sudden change in the middle, that one has a more change. For instance, if you multiply this one, let's see. One, two, 1, 2, 2, 1, 3, 0, 1. Achha. What will happen if I multiply? -1, -2, -1, -2, -16. Sorry, +16. -1, -3, +0, -1. তাহলে কত আসছে? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. -11 +16, that is equals to 5 divided by 9. That is equals to 0.5 or 6, something like this. 0.55. So what do? You replace this value, the center pixel values, with 0.55. Okay. So is there any high frequency component in this image? Okay.
Yes, sir.
Now, এখানে কোনো high frequency component নাই. All of them are similar. So you are replacing it. Every values, low frequency components gets lower. But see, instead like this, if this value is instead of 2, this value, let's suppose this is 20. তখন কি হইতো? 8 দুগুণে 16, দিস উড বিকাম 160, তাই না? তখন
Yes,
কি
sir.
আছে? -11 প্লাস 160 কত হয়ে যাচ্ছে? 149. If you divide it by 9, so 9, 5 65, 60. Okay, so you see something like this, 16 or 17. So all the other values getting lower and lower, but the high frequency value, that one is preserved. Okay, so it will reduce the low pixel values, but the high pixel value will get only higher. Not higher, but it will preserve the high pixel values. Are you following?
Yes, sir.
So this way, the high filter components, okay, it will actually preserve the edge information. It will preserve the edge information, edge or texture, high frequency values. It will preserve the edge or texture images, and it will remove the other information. To some extent, it will remove the other information. Achha. So the problem with this one is that it actually eliminates the low frequency component, eliminate but reduce the low frequency component. But low frequency component actually contains most of the information of the image. So if you eliminate too much of the low frequency component, that is not actually good. You can check the book. Okay. In the PDF, it may not be very clear. I also could not get the images that are actually they are working on. It will be much easier to show you the effect if I had the images that are available in the book. So if you look at Splinter book, chapter 3, I think, chapter 3, you will see the operation. Okay. Of this high pixel filter or low pass filter. Sure. Now, this one, like this problem, this low frequency component reduction. So high pass filter is sometimes replaced by, without using high pass filter, there is a variation of the high pass filter that is called high boost filter. It's called high boost filter. Now, so what high boost filter does, it highlight the high frequency, just like high pass filter, highlight high frequency component, just like the high pass filter, also while preserving low frequency components. Okay. So it will highlight the high frequency component, but also preserve the low frequency component. It will not reduce those or eliminate those things like that. That's it. Now, so if you look at this mask, what will this mark will perform on the image? এটা কি পারফর্ম করবে? What will it do?
এটা কি কনভলিউশন করবো?
কি মনে হচ্ছে? If you pass it through the image, pixel values কি চেঞ্জ হবে? What will be the change if you multiply your image with this one? চেঞ্জ থাকবে কোনো?
না স্যার, না স্যার।
It will not change anything. You see, all the surrounding pixels are zeros, and the center pixel is just multiply one with one. So this is called a all pass filter. Okay, because it does not modify your image. So in high boost filter, let's say this is your A all pass filter. In high boost filter, this is high boost filter. What do? You perform an operation like this: A minus 1. আচ্ছা সরি, এটা তো এ না, আমার all pass filter. So A is a value multiple by, এটা হচ্ছে all pass filters, এটা হচ্ছে APF লিখি, So A minus 1 multiple by APF plus your high pass filter. So you see all pass filter, no change, no modification. So what you are doing in high boost filter, this is like a concatenation of two different filters. One portion is the high pass filter operation. So you are doing whatever the high pass filter is doing. Okay, acha. But you are adding this one, the original image, whatever the original image you have, you are adding that image as well, but a weighted version, slightly weighted version of the image. Weighted means if A is equals to 1, then high boost filter will be equals to high pass filter, তাই না? 1 minus 1 0 গেল। If A is greater than 1, then this filter is multiplied by some weight value. Weight value is what? A minus 1. So if I use 1.5, then A pass filter in high boost filter, this will be multiplied by 0.5 multiplied by the all pass filter plus this high pass filter operation. So this is performing, but after that, this gets add up 0.5 and weighted of the original image. Okay, you see, this one will highlight the high frequency components, and this multiplication will produce a portion of the low frequency components. Okay, if you use different values of A, you will get different level of variation, slightly different, but you understand the point, right? আমার কথা বোঝা যাচ্ছে?
Yes, sir.
So you are like putting one image, you perform the operation, then add another filter there. So that your original image does not get suppressed like this way. Acha. So this is your high boost filter operation. So these are some of the filters that we use, commonly used in filter. There are several other filters. Okay, like hybrid filters are there. Derivative filters are there. You use more than one derivative. We'll see. Also, you can consider frequency domain operation as well. Okay. You can also consider frequency domain filtering in terms of image as well, but it depends on what kind of operation you are doing. When you are using image, it is much more easier to consider the filtering operation in the spatial domain. Okay, that's why you are focusing on spatial domain. But there are also high frequency. You can also same low pass filter you can consider for high frequency, low pass, high pass, then Butterworth, things like that. Okay. You can ignore this portion from the book. Achha. Now, this image processing is a very large topic, and there is one book I actually provided to you. This one. So this book, this is the handbook of medical image analysis, processing and analysis. This is a very large book, okay? And all the image processing, if any of you is very much interested in image processing, okay, particularly in image processing operations, you should look at this book because everything that you do is much more details in this book. Okay, very detailed. But this is not only our only topic, so we need to ignore so much detail. But everything that you do in different types of images, like how you extract the features, okay, how you extract the textures from different types of images. For ultrasound image, there are different techniques for texture analysis. For MRI image, there are different techniques for segmentation. Okay, for X-ray image, we have one type of segmentation. For MRI imaging, you have different types. So there are lots of variation in the image processing techniques. So if you are very much interested in those ones, you can actually follow this book. Or if you just want a summary of these things, you can actually follow the Splinter book for now. So this portion, whatever I have covered so far, some of the very basic operations on the images. Today we talked about the filtering operation. Okay, image filtering. Basically, we saw some 4 different types of filtering operations, and previously we saw the image enhancement, some of the image enhancement techniques. Okay, Achha. The last topic. So just like these operations, we try to consider the low frequency, high frequency. And more specifically, sometimes we want edge detection. Okay. Specifically, we want edge detection. We want to detect the edges, identify the edges. When, for instance, you have a cell image. In the cell image, you have the nucleus, and you want to identify the the contour of the shape of the nucleus. Okay. In the lab, I have provided one example of this one. So you want to detect this portion. Okay. You want to detect this portion. This is also falls under the segmentation. We'll talk about segmentation in the next class. So you want to identify the edge details of the image to separate different objects in the image. So that kind of function, that is also one type of filtering. This is called edge detection filter. Okay, there are different edge detection filter. And I think you are already familiar with this one, so I'll just quickly cover this one. So there are different filters like Sobel filter. Okay. Then you have Laplacian of Gaussian. Laplacian of Gaussian or LOG filter. Then you have Canny. There are others as well. There are other filters as well. So there are different edge detection filter. And the operation is somewhat just like the same filtering operation in the in the spatial domain. For instance, if you look at the Sobel filter is very simple. It is the you can see it is the simplest filter. So if you are doing a filtering operation like this, it can come like this way: 1, 2, 1, 1, 2, 1, 0, 0, 0. So that is a Sobel filter. So what kind of edge will it detect? What kind of edge will it detect?
Vertical.
Vertical. SV. So this is a vertical edge. আচ্ছা, let's see how it can detect. Okay. So ধরো তোমার ইমেজটা হচ্ছে like this. Very simple example. Let's say this is your image. So 0 and 1 means if you consider this one, this image actually looks something like this. On the left side, you have the black regions. So on the left side, you have the, the 0 means black. Okay. On the right side, you have this black regions. Okay. Completely black. Okay. And the left side, you have the white regions because these are 10. So you see, in between this boundary, this region, this is the edge, right? This is the difference, sudden change. So if I multiply this one with a Sobel filter like this, for instance, 110, just simple 111. Easier operation. Okay. If I multiply with this one, what will happen to the output? First, you put this one in this 3x3 region. So if you multiply this way, what will be the output? 1/10, 10/10/10. So 10 plus 10 plus 10. Then you have 0 plus 0 plus 0. Then you have -10, -10, -10. So in total, 0 আসতেছে না? Are you following?
Yes, sir. Yes,
So you have this 0 here, then put a little bit downwards. You again have 0 here. You will again have 0 here. You will have total 4 0. 6/6 will be reduced by 2/2. So it will become 4/4 size. Then you actually shift your filter here. Okay. Now you see, you don't have no longer have this -10. So this becomes now 0. So you have in total plus 30 here, right? So these values will be 30, 30, 30, 30. If you again shift it, this will also become 30, 30, 30, 30. And at last you will have 0, 0, 0, 0. Try these values, calculate the values, and you will get the output like this. So see what is happening here in the output compared to this one. What is happening in the output? On the left side here, you have this completely 0, means completely black. And the right side, you also have completely black. In the middle, you have this 0. So the age information, wherever there is a change, wherever there is a change in the two different segments, that portion becomes highlighted in the output of the Sobel filter. Okay. Are you following? আমার কথা বোঝা যাচ্ছে?
Yes, sir.
So in the left side of the image, whenever there is left to right side, whenever there is an age, that age gets highlighted like this way. The age information gets highlighted in this kind of Sobel filter operation. Okay, this is a very simple operation. So it can be like vertical, it can also be horizontal. You make these things 0. So this will be a horizontal operation. And sometimes in the image, you want both the horizontal edges, also the vertical edges, right? So you use a combination of these two, both of them. First, you pass it through a horizontal, then pass it through a vertical, then adjust together. So you use a combination of this. Okay, so this is a very simple operation, Sobel filter. If you want to go to a more advanced one, these two are a bit more advanced and usually outperforms the Sobel operation. Okay, just to summarize these things, Laplacian of Gaussian. So there are two operations you are doing. First one is a Gaussian smoothing filter. Okay, Gaussian smoothing is a kind of low pass filter that allows you to reduce the noise. So Gaussian smoothing filter. And another one is the Laplacian operator. A Laplacian operator মনে আছে? Laplacian হচ্ছে second derivative নেয়, তাই না? আচ্ছা, so you see, when you perform this Sobel filter operation, you are only considering the direct operation, like the first derivative. You're only considering only the one segment, direct operation. But when you do this one, first derivative like this way, some of the edges, like weak edges, if the value difference is not very sharp between these 2 points, then those kind of edges will not be identified by the Sobel filter. So this is like weak edges. The difference is very small between the edges and its neighborhood pixels. Those weak edges will not be identified in the Sobel filter. But if you take second derivative of whatever the value is, so this will amplify those details, amplify the details in the first derivative, whatever you have, these weak edges will get amplified. So it will be able to actually highlight the edges more better than the first derivative. Okay, so when you take the Laplacian operation is like this, del x square, things like this way. When you perform the Laplacian operation, it will be able to better highlight the edges. Okay, but it will also amplify when it amplify the edges. So it is amplifying the edges, it will also amplifying the noise. That's why to suppress these noisy operations, you add a Gaussian smoothing filter there. You add a Gaussian filter to suppress this noisy portion. Is it okay? আমি কি বোঝাতে পারছি?
Yes, sir.
আচ্ছা, so this way you first actually apply this Gaussian filter to avoid this kind of noisy pixels, then you perform the Laplacian. Okay, that's what this Laplacian of Gaussian actually do. You don't have to go to details because the application, you can apply those things very simply with a function using MATLAB or in Python as well. So you don't have to go to very details of these operations. Okay, just know these operations, that will be enough. If you need something, so you can easily go back to these things. Kenny is much more popular. It's a little bit more complex, more popular, also a little bit more complex as well. So it actually performs lots of different operations. It performs the Gaussian filtering. Okay, it performs the Gaussian filtering. It also calculates the gradients to highlight the edges. It also performs suppression. Because it performs a kind of suppression techniques. It also performs thresholding. So it performs a lots of different things to get the total output. Okay, so this Kenny actually is usually supposed to be the best of these three. The log filter is also very nice. So these are different edge detection technique. Okay, you can apply those things on your image and see how this edge detection actually works. So if I give you an example to Sorry. So look at this one. You are already, I think, familiar with this one, the cameraman. So you see, this region is completely black, so no change. So these things are completely white, so no frequency components, no change. And this is the edge, the border line. Okay. And you are interested in this border. So when you perform, you can take this one. This is cameraman.tif. If you search for cameraman.tif in your in your MATLAB, that file is already there. So you see the sharp, the edge details, the boundaries. This is very clearly visible here. Also look at this one. You see the hair, even the hairs are also very nicely identified this region. So this is what the edge detection filter actually. This is what the edge detection actually supposed to work. See, for instance, this one. So if you are looking at an MRI image, okay, and there are different segments. When you take the edge detection, it will actually provide an image like this. So this is from the ultrasound, X-ray mammography. In the mammography, we want to perform this kind of edge detection, okay, to identify the faulty regions. Faulty means the regions with tumors or things like that. So you can actually use this kind of edge detection in medical imaging like this way. Acha. Any questions so far? So today we talked about mostly filter operations, and we saw some of different types of filters. Okay. One was the normal low pass filter, high pass filter to get a smooth version of the image, or sometimes to highlight the edges, the high pass or high boost filter, and particular some special filters like Sobel filters that actually provide the edge detection approach. Okay. So all of these are pixel based, right? In the spatial domain, you're processing the images using masks. So mask processing operation. That's in the next class, we'll talk about more details about segmentation and some kind of transformation. Okay, any question? Any question?
No, sir.
Acha, so you can actually, let's finish it today. You can write your ID in the chat.
স্যার প্রজেক্ট নিয়ে কিছু বলবেন?
হ্যাঁ
প্রজেক্ট নিয়ে স্যার।
হ্যাঁ বলো, এনি কোশ্চেন প্রজেক্ট নিয়ে? ও আচ্ছা, তুমি একটা মেসেজ দিস, আমি ওটা ভুলে গেছি, আমার এখনই মনে পড়লো। আমি একটু মাঝে মাঝে ভুলে যাই তো, অনেক মেসেজের মাঝখানে একবার রিমাইন্ড দিবা, 2-3 দিন পর যদি রিপ্লাই না দিই একবার রিমাইন্ড দিবা, আমি দেখবো এখন। Any questions regarding your project? Anyone else? Try to find some, you can do based on image processing, you can do about signal processing. We'll start with signal processing. Okay, next. Like ECG signal processing, EEG signal, EMG signal, different types of signal. You can also work with signal processing. Okay. So you can work with image processing. You can work with predictive modeling. Okay. You can work with segmentation. MRI image segmentation is an important part. So volumetric image, so MRI data, that's a different part. You can work with any of them. Okay. Don't be afraid to do those things. Okay. I will try to cover a lot. I am trying to cover a lot of things in the lab, but some of the things it is not possible to cover. For instance, MRI image processing, I don't think it will be able to cover those things. You can just search, like in MATLAB have one type of, I think MATLAB have a separate toolbox. Okay, a separate toolbox as well as a GUI for MRI data processing. You can also look at this one. So try to do something new by yourself. Okay, try to look at something new. There are different online information available. Try to look at them. You will find some good projects there. Any question? So try to, whatever your project idea is, try to finalize it by this weekend. Okay, by this Friday, and write a summary of what you want to do, what is the purpose, and how you are planning to do this, so that I can give you some suggestions later when we check those things. Acha, you can write, Fariba, you can actually write it today. Acha, that will be enough. সাদিদ
স্যার আর স্যার ল্যাব 2 এর অ্যাসাইনমেন্টটা মানে কোনো ডেডলাইন নেই, এটা কি স্যার পরে দিলে কি
কোন
সমস্যা হবে?
অ্যাসাইনমেন্ট? আচ্ছা
স্যার
ওয়ান
ওই যে স্যার ল্যাব 2 এর যে অ্যাসাইনমেন্টটা ছিল ওটা তো স্যার কোনো ডেডলাইন দেননি স্যার, ওটা এখনো জমা দেওয়া হয়নি। সমস্যা তো হবে না না?
হ্যাঁ, আরেকবার বলো, আমি ফোন আসছিল, আরেকবার বলো।
স্যার ওই যে ল্যাব 2 এর অ্যাসাইনমেন্ট যেটা আছে ওটা কোনো ডেডলাইন নেই, এটা স্যার এখনো জমা দিইনি,
আচ্ছা,
সমস্যা তো হবে না স্যার?
হ্যাঁ দিয়ে দিও, ওটা দিয়ে দিও। ল্যাব 3 তো ল্যাব 4 এর আগে দিয়ে দিও, এই উইকের মধ্যে দিয়ে দিও, এই উইকেন্ডের মধ্যে।
আচ্ছা
আমি
স্যার।
খেয়াল করি, ওটা আমি
আচ্ছা
ডেডলাইন দিয়ে দিচ্ছি। ওটা কি ছিল? ল্যাব 2? আচ্ছা ওই
নেক্সট
যে
উইক, নেক্সট উইকেন্ড পর্যন্ত রাখুন স্যার, মানে এই উইকেন্ড, আরেকটা উইকেন্ড রাখুন।
ল্যাব 3 তে কোনো অ্যাসাইনমেন্ট দেয়নি
না স্যার।
আহ, কি বলে ওর নাম? ল্যাব 3 কি তোমাদের শেষ হয়েছে?
স্যার দুইটা গ্রুপের শেষ মেবি।
ল্যাব 0 কি ছিল? আচ্ছা, জাস্ট হচ্ছে যে ইয়াগুলা, এই তো এই জন্য তো, এটা তো পরীক্ষার আগে করলে তাহলে একটু কাজ আসতো। উম, আচ্ছা, এটা আমি আজকে কয় তারিখ? 27 না? 29, 30, 31, 32, এক। আচ্ছা, নেক্সট নেক্সট ওকে। এনি মোর কোশ্চেন?
স্যার আজকের ক্লাসের আর লাস্ট ক্লাসের ভিডিওগুলো
হ্যাঁ,
যদি
আমি আপলোড
আপলোড
করে দিব
করে
এখন।
দিতে। ওকে স্যার।
মানুষ এত ভুলে যায় কেন? এটা কি ভুলে যাওয়া সিনড্রোম হচ্ছে? শর্ট টাইম মেমোরি লস। হচ্ছে মঙ্গলবার না তাহলে? নেক্সট কালকে হচ্ছে বুধবার। তো বুধবার সকালে ক্লাসটা তাহলে হচ্ছে না। নো ক্লাস টুমরো। সিয়ার একটু জানাই দিও, আমরা আরেকটা অনলাইন ক্লাসে নিয়ে নিবো এখন।
স্যার নেক্সট উইকের ক্লাসগুলো কি অনলাইনে হবে স্যার?
কালকে ক্লাসটা অনলাইনে না নিয়ে কালকে, তোমরা কি দুপুরে ফিরে আসো কালকে, লাইক 12টা 11টার দিকে?
স্যার কালকে অফলাইন ক্লাস আছে স্যার অনেকগুলো।
হ্যাঁ,
স্যার কালকে অফলাইন ক্লাস আছে অনেকগুলো।
অনেকগুলো, সেটাই ভাবতেছিলাম। একটা ক্লাস, আমারও তো ক্লাস আছে। কাদের সাথে আছে কালকে? সেকশন বি?
ইয়েস স্যার।
এই সকাল 9টার সময় ক্লাস নিতে যাওয়া প্যারা।
স্যার রমজানে স্যার অনলাইন নিয়ে নেন স্যার।
আচ্ছা ঠিক আছে, নিচ্ছি। এখন হেডসেট ধরলে তখন আবার ঝামেলা। আচ্ছা, যাই হোক, হবে এখন।
স্যার নেক্সট উইকের ক্লাসগুলো কি অনলাইনে হবে নাকি ওগুলো অফলাইনে হবে স্যার? নেক্সট উইক
আপাতত এই উইকটা বাঁচে থাকি, তারপর নেক্সট উইকটা চিন্তা করে দেখবো।
স্যার যদি অনলাইন হয় তাহলে স্যার চলে যাওয়া যেত, টিকিট কেটে ফেলতে।
প্লিজ স্যার আগে
নেক্সট
থেকে বলে দিলে ভালো হয়, কারণ
স্যার
পরের উইকে
অনলাইনে
ঈদ।
নিয়ে নিন স্যার।
স্যার
ওয়েল,
মানে
এই উইকে
ট্রেনিং
কোনো সমস্যা নাই, এই উইকে সমস্যা। নেক্সট কয় তারিখ? নেক্সট তোমাদের কি 5 তারিখ থেকে বন্ধ শুরু না?
জি
জি
স্যার
স্যার।
শুরু কিন্তু
5 তারিখ থেকে বন্ধ শুরু। Well, এটা আসলে আমি আগে থেকে, আমার কোনো সমস্যা নেই, আনলেস হেড স্যার কোনো প্যারা দেয়, আমার কোনো সমস্যা নেই অনলাইনে নেওয়ার জন্য। ঠিক আছে, আনলেস যদি স্যার এরকম খবর পায় যে সব ক্লাস অনলাইনে হচ্ছে, তখন স্যার মিটিং আছে আমাদের একটা, মনে হয় শুক্রবার, তখন যদি বলা শুরু করে তখন ঝামেলা। সো উইকেন্ডে হয়তো, উইকেন্ডের মধ্যে আমি শিওর জানাতে পারবো, বৃহস্পতি শুক্রবারের দিকে। আনলেস স্যার কিছু বলে, আমার অনলাইনে নিতে কোনো সমস্যা নেই। আই উইল ট্রাই টু মেক ইট অনলাইন। ওকে।
ওকে
বাট
স্যার।
ওই যে বললাম, সব ক্লাস যখন অনলাইনে নেওয়া শুরু হয়, এই খবরটা যখন ভিসি স্যারের কাছে চলে যায় বা হেড স্যারের কাছে চলে যায়, তখন স্যাররা ভেজাল করে, তখন ঝামেলাটা হয়ে যায়। আচ্ছা, ঠিক আছে, আমি স্টপ করতেছি।
স্যার মিডের বাকি খাতাগুলো কখন দেখাবেন?
আহ মিডের আরো দুইটা দেখা হয়েছে, আরো 25 জনের মতো দেখা হয়েছে।